Very good morning, students. So myself, Dr. Eustace Russell, working as an assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called Engineering Mechanics, subject code ME25C25 at the regulation of 2025 for the first year students, second semester. So for the previous lecture videos, we have completed up to 3 parts in Unit 2 successfully in statics of rigid bodies. Now we are going to see the last part of this Unit 2. We will go through one by one in the upcoming slides. This slide represents the reactions and the support reactions. As I already told, whenever there is a point of contact, we'll have a reaction support, one force that will be acting in a perpendicular direction, that we already discussed in the last video, that is part 3 video of Unit 2. When the number of forces are acting on a body and the first body is supported on another body, then the second body exerts a force known as reactions on the first body at the point of contact so that the first body is in equilibrium. The second body is known as support, and the force exerted by the second body on the first body is known as support reactions. Okay, the first body is supported on the other, then the second body exerts the force known as reaction on the first body. Okay, automatically whenever the point of contact, one reaction will be acting in that point, that will be perpendicular. So 5 important supports that are mentioned here. One is simple support or knife edge support. Another one is roller support. Next one is pin joint or hinged joint, smooth surface support, fixed or built-in support. We have a simple supports or a knife edge support. We have a diagram in this. 2 supports are there, right, in the beam. In the another one case, in the right hand side, we are having a roller support. In this diagram, we don't have any roller. It is a simple support, simply supported on 2 pivots like that. In this case, support will be normal to the surface of the beam. If AB is a beam with knife edges A and B, then RA and RB will be the reaction. In the second diagram, we can see RA is acting perpendicular upward, RB also acting in the direction perpendicular. Then roller support. Here beam AB is supported on the rollers. The reaction will be normal to the surface on which the rollers are placed. Here also the same thing. Whenever it is the beam is supported over the rollers, it also having the same reaction what we discussed in the previous thing, RA, RB. Pin joint or hinged support. Here the beam AB is hinged at a point A. One point is there. Reaction at the hinged may be either vertical or inclined depending upon the type of loading. If the load is vertical, then the reaction will also be vertical. If the load is inclined, then the reaction at the hinged end will also be inclined. Whenever it is inclined, it have the 2 components, that is vertical component and the horizontal component also should be taken into account. If it is a fixed joint, fixed or built-in support in the right hand side, in this support, in this type of support, the beam should be fixed. The reaction will be inclined. Also, the fixed support will provide a couple. In the end point, we have the couple will act at the end point. It will exert one couple. Then types of loading. In this slide, we are going to discuss about the various types of loading. First is concentrated or point load, uniformly distributed load, uniformly varying load. First is concentrated load or point load. So whenever the load is acting as a point, in this diagram you can see one point load is acting. So beam AB is simply supported at the ends A and B. Load W is acting at a point C. This load is known as point load or concentrated load. Here any load acting at a point on the beam is known as point load. One load will be there, acting will be at particular point. UDL is totally different. We can see in the diagram. It will be uniformly distributed. That is called UDL. UDL is a force applied evenly across the entire length or surface area of a structural element such as beam or slab rather than at a single point. Uniformly varying load. Uniformly varying load can be classified as a load that is distributed along the length of the beam or structure but varies linearly throughout the length of the beam. So for example, in the staircase, like that example, we can see the load will be gradually increasing. First step will be the less force, second step will carry another one force. So it is gradually it is increasing. So it is uniformly varying load. It is uniformly varied. In some case, we can see some slope will be there. In car parking area, we are driving the car above the parking area. One slope will be placed over that particular area. The slope is uniformly varying load at one point to end point. So now we will follow some basic examples in this slide. First example is one simple problem which I took here. A simply supported beam AB of span 6 meters carries point load of 3 kilonewton and 6 kilonewton at a distance of 2 meter and 4 meter from the left end, as shown in figure below. Find the reactions at A and B analytically. We can see one diagram. A and B is there. First of all, 3 kilonewton and 6 kilonewton, 2 meters, 4 meters and 6 meters is there. Span of the beam is given as 6 meter. Then reaction RA, that is reaction at A is taken as RA. RB is reaction at B. As the beam is in equilibrium, the moment of all forces about any point should be 0. Now taking the moment of all the forces about the point and equating the resultant moment to 0, we get, now we are taking the moment RB into 6. It is RB into 6 minus 3 into 2. In some books, clockwise will be taken as negative, anti-clockwise will be positive. Like that. Minus 6 into 4 is a clockwise only, but some books they are following minus 6, some books they are following positive also. We can use any direction, but the final answer should not get varied. That is the main problem. That thing you have to keep it in your mind. Okay. AB equal to 5 kilonewton. Also for equilibrium, sigma Fy equal to 0. Then in this case, summation of all vertical forces, that is RA plus RB equal to 3 plus 6, that is equal to 9. That is RA equal to 9 minus RB, that is 9 minus 5, that is 4 kilonewton. Second example, that is simply supported beam AB of span, that is 5 meter is loaded as shown in figure. Find the reactions at A and B. Now we have the beam AB having various loads. These are point loads. As I already told, the load that is acting at one particular point, it is known as point load. So what are the point loads here? 5 kilonewton, 4 kilonewton and 3 kilonewton. At some distance it is varied from point A, some 2 meters. From 8 to 4 kilonewton is 3 meters. From 5 to A is 4. The remaining will be 1 meter. The same procedure you have to follow again. You have to take RA, the reactions RA at B, RA at A. Then what you have to do? Taking moment about point A, you will have that expression, that is RB into 5, which is equal to 5 RB kilonewton meter, and the summation of clockwise movements about the A we are going to take, that is 3 into 2 plus 4 into 3 plus 4 into 3 plus 5 into 4, which is equal to 38 kilonewton meter. Now equating anti-clockwise and clockwise movements given in 1 and 2, 5 RB equal to 38. 5 RB equal to 38. That is RB equal to that is 38 by 5. That you will get 7.6 kilonewton, the final answer. Then you have to substitute in that value, you will get RA equal to 4.4 kilonewton. Then this slide having a uniformly distributed load. This kind of problem is very, very important, mostly in university. This type of problem only they will ask. What you have to do means, length of the simply supported beam AB of length 9 meters carries a uniformly distributed load of 10 kilonewton meter for a distance of 6 meter from the left end. Calculate the reactions at A and B. What are the reactions? RA and RB. Then distributed load is 10 kilonewton per meter for the 6 meter. Then we have to take length of the beam is 9. then the rate of the UDL, that is 10 kilonewton per meter. Length of the UDL is 6 meter. Then total load due to UDL is length of the UDL into rate of the UDL. So how much it is spreaded, that is important. 6 into 10, that is 60 kilonewton. This load of 60 kilonewton will be acting at the middle point of AC at a distance of 6 by 2. 6 by 2, because UDL will act exactly at the midpoint of the beam. So wherever it is spreaded, it will act at the midpoint. From A, there is 3 meters only. What is RA? Reactions at A. RB, reaction at B. Now taking moment of all forces about point A and equating the resultant moment to 0. And finally, RB into 9 minus 6 into 10. What you are going to take means 6 into 10. Okay, right? So we are having RB into 9. Then that is 10 into 6 means the spreaded load into how much it is spreaded. We have to take the half of the distance, that is 3. Finally, you will get RB equal to 20 kilonewton. Also for equilibrium, sigma Fy equal to 0. Finally, RA plus RB equal to 60 into 10, that is 60. Then RA equal to 60 minus RB, 62 minus 20, 40 kilonewton you will get. Then the next is the same problem. Again, we are going to taken for your understanding purpose. Similar problem only, same problem. That is support reactions. We have the beam AB 5 meter long, supported on 2 intermediate supports 3 meter apart, uniformly distributed load of 0.6 kilonewton per meter. Beam also carries 2 concentrated loads, that is 3 Newton at the end, left end A, and the 5 Newton at the right end B, as shown in figure below. Determine the locations of the 2 supports so that both the reactions are equal. Now we can see this diagram. Uniformly load is distributed, that is 0.6 kilonewton per meter. It is distributed through a length of 5 meters. We can see it is 5 meters. Length of the beam AB is 5 meter. Span L is 3 meter. RC is reaction at reaction at C. RD is reaction at D. X is the distance of support C from the left hand end. Now total load we can add 3 kilonewton plus 0.6 into 5 plus 5. 0.6 into 5 means the distributed load into how much it is distributed. That is a total load. That is 0.6 into 5 we have taken. Then plus 5 is the another one point load. Then the reactions RC and RD are also equal. Then it is 11 by 12, that is 5.5 kilonewton. We know that anticlockwise movement due to RC and RD about A, it is 5.5 into x plus 5.5 x plus 3 equal to 5.5 x plus 5.5 x is equal to 16.5 kilonewton meter. 11x plus 16.5 kilonewton meter. Sum of clockwise movement due to load about A. We are taking the clockwise movement, that is 0.6 into 5 into 2.5 plus 5 into 5. You will get 32.5 kilonewton meter. Now equating anti-clockwise and clockwise movements given in the equation 1 and 2. Therefore, you will get 11x plus 16.5. We are going to equate both these cases. We are going to equate. So the first support will be located at the distance of this much, 1.45 distance. The reaction will occur. So this is for your reference, students. Please go through this reference, which I prepared the content based on this reference only. So thank you all for your kind attention for listening this lecture video. Kindly subscribe the channel and share this video to your friends. And please do the problem based on the slide and practice well. We will see in the upcoming videos. Thank you.